Okay, no secret, AI driving unprecedented demand at the current time. How is this surge fundamentally changing the relationship between data centers and the electricity grid?
No, that's a very good question, and definitely the AI brings the complete change in the data center industry. So the demand for the electricity is huge. If we look according to McKinsey, additional 125 gigawatt of energy will be needed in the next 5 years. To give the perspective, that's equivalent to the energy demand installed capacity of country like Spain. So we really need to build a new Spain, right, to support the next generation of the data centers. And we really need to work together across the segment, across the data center, and closely linked to the utility. Still, the number one priority for the data centers is the grid connection and the power which is coming from the grid. So definitely there needs to be a close link between the data centers and the utilities.
Yeah, and so what are the most urgent ways that the electricity grid has to evolve in terms of supporting this rapid expansion of the AI-driven data centers? What are the things that need to be prioritized?
Yes, I would say there are multiple ways how this should be done. Today, we are looking at the generation, and you know that the data centers are looking to the direct access to energy that are installing the generation capacities, including the solar, wind, of course, gas. One example is that the lead time of the gas turbines increased from 1 year, just 1 year and a half or 2 years ago, to more than 3 years. And this demand is purely driven by data centers, which need more energy and more power. Still, there is power in the grid available. The challenge is how to bring this power to the data center users and how to make it available and reliable because we always need to keep in mind that the data centers are critical power. So they need available energy 24/7. And here, I would say that we need to find the ways how to flexibly operate this power and energy, how to make sure that is available at scale, and how to make sure that we balance between the demand and fastly fluctuating demand of the data center and a little bit more slowly, right, fluctuating the production of especially the renewables, but also the other energy sources. So solutions like battery energy storage systems, like fuel cells or other means of the energy storage definitely can contribute to access to those new energy capacities from the grid and which are actually available. Just we need to find a sustainable and accessible way to bring them to the data centers.
Okay, but nevertheless, I think it's fair to say that energy availability is a key constraint in terms of the data center expansion plans. How serious? I mean, I talk to different people and they all have slightly different views, but I'd be interested in your thoughts as to just how serious is this bottleneck and what it might mean for the future data center growth. I mean, is it going to really constrain or is it not as big a problem as maybe people think?
I would say the challenge is real, and actually we need to find the ways how to enable the growth of the data center industry in a sustainable way. So definitely we see the data centers installing also the local energy production capacity. We know that the primary right business of the data center is not the energy generation, is not the playing in the energy industry. Still, if you can't find the access to energy from the utility, there are alternative ways, right, how to bridge this power or even in a long-term run in the island mode, and we can definitely support. Now, of course, there are ways to overcome this, and we need to again collectively work right towards finding the solutions. So again, examples, right, where we can bridge this power for a couple of years before the utility becomes available is one of the key aspects, right? Again, the storage there is really needed because to balance and to trade between between the local generation and, for example, gas engines and fast fluctuating loads of the AI data centers, especially. And then also make sure that once grid connection is available, that we can connect this asset to the grid so that it becomes also active grid participants and contributes to the grid stability and contributes to the energy itself, right, which is available on the grid. So I would say the challenge is real. The challenge is happening. We are seeing it in the industry. Still, I would say there is a chance and there is the opportunity to overcome this challenge, to find a way how we deal with it in a short term, but very important to ensure that what we are installing today and how we are operating data centers today, that it enables the sustainable growth. And eventually, once those data centers become part of the grid, become part of the connected to the utilities, that they contribute in an active way to the stability and to the operation of the grid itself.
Yeah, so I think you probably answered most of my next question, but I'll ask it anyway. Data centers, they're going to become part, active participants in the grid rather than just the consumers. But sort of longer term, as you say, they're not, their primary business isn't generating power energy, but and they're sometimes reluctant to get involved for that reason. Just your thoughts, I suppose, as to how realistic is that expectation that they will sort of be heavily involved in, if you like, the energy generation, because it obviously suits their own needs, but it makes them look, as you know, they're a little bit under pressure, shall we say? So if they're doing that kind of activity, it improves their profile. Yeah, just any thoughts you have as to how far they might become active participants?
Yeah, no, very good question. And you're right, right? As you said, the primary business of data center is data center loads, cloud operation, producing tokens from the AI, not really, right, energy generation, or not really the utility or IPP business. Still, we see that the data centers are heavily investing in this piece and realizing the opportunity that again they can really contribute to the even society, right, and to the grids and to the utilities itself. And we see the examples where the utility helps them connect quicker once they can show the plan how they are gonna contribute, right, to the demand response or to the stability or to any other ancillary services that they can now do actually because of having the grid assets like again, of course, generators, turbines, solar, or anything else, and extremely importantly, the battery energy storage system, for example. And then it comes how you operate it, all this, how you orchestrate all this, how you connect those assets together with the utility to ensure, again, that you can really contribute and do perform the ancillary services to the grid when it's needed. So I would say maybe today is not yet the case, right? Because if we look 2, 3 years ago, it was relatively easy for a data center to get the grid access because data centers were not bigger than 100 megawatt or something like that. We now have those gigawatt scale data centers. We, of course, see the huge install base, right, of also generation directly connected with the data centers itself. So it's a matter of time when we will see the first data centers becoming really, again, the grid assets and supporting the grid itself. And we are seeing from the Hitachi Energy, and we are supporting the data center customers to identify what are those opportunities. We are the company, right, mainly who is dealing with the utilities, and this is our traditional business of more than 100 years, right, being in the utility. In the data centers, we started very early, right? Early days, we were just seeing few data centers which would have a grid connection, right, and building the substations. Now, majority of them do have this. And we are supporting to bridge this gap, I would say, between the two industries, right? The utilities and the data centers itself, and help them, right, to become part of the grid and make sure, again, that they can contribute, they can do all the ancillary services and become active player and flexible player of the grid.
Okay, and in terms of resilience, I mean, I guess it's always been important, but it's getting more and more important, just I guess because so much relies on data centers. Um, are there ways that operators can help or improve the stability of uninterrupted power while this demand continues to climb? So I say, is what they're doing now okay, or do they need to look to take extra measures, shall we say, to protect their resilience?
That's a very good question. And I believe compared to what we saw maybe 5 years ago or even 2 years ago, how the resilience is being built is over because simply you can't build one-to-one, right, backup power to the grid power simply because of the huge demand of the data center for the energy. And there's not enough available diesel generation or gas generation and so on. So you really need to rethink how you build the data center infrastructure. And there is the opportunity actually with this direct access to energy and with the assets you are building for this, what we call bridging power, right? Before the energy becomes available. Also can be used as a backup power. The utility itself, right, is also building the more assets within the grid and is very available and very reliable. As the data center grows bigger to the gigawatt scale, you can also think of having a redundant grid connection and the utility connection. So with a proper planning, with a proper studying, with really day zero planning, you can build the resiliency in a different way compared to the traditional one-to-one local generation and the utility connection, which then right enables you to do all this together, I would say, right? Have the reliability and redundancy to the grid in case that there is a outage from the grid and you need to operate locally, but also use those assets actively, right? Once the grid and the utility is there, keeping some capacities as a reserve in case you need to connect the loads immediately. And in addition to that, you need to carefully study the loads you have in your data center. Maybe not all of them are critical all the time. When you're doing, for example, the AI training, that can be interrupted in some cases, maybe inferencing not. And of course, if you're performing some critical actions with the loads, you can't interrupt them, and you need to make sure that you have enough backup power in your system. And here comes the importance of linkage between the loads, between what's happening actually in the data center itself, between your energy assets that you have installed around or inside of the data center. And then, of course, the availability of the grid and the grid assets itself, and how much energy you can reach at a certain points from the grid and from the utility to your data centers. So flexibility of the operation, I would say, is the name of the game, and good planning in the initial stage.
Yeah, and you're getting good at I think answering my next questions. No, but I don't think you completely. So I'll ask, in terms of advanced grid technologies and flexible connection models, how are those enabling data centers to secure reliable and renewable energy at scale? So what developments are we seeing there?
That's a very good point, and actually we can add to what we
Mm.
said already, right? Definitely the no one could expect, right, such a huge demand from the data center industry and the AI developing so fast and actually requiring so much energy. And there, maybe the aspect that we didn't mention yet is also the load profile of the AI data centers. If you look to the let me call it traditional cloud services or digital and other service data center, the load is very stable and very predictable. The load of the AI data center is fastly changing and fastly fluctuating, which can be very challenging to the grid assets. And we see already the grids understanding this challenge, but also investing into the new models, how the grid can be operated, or also the solutions which improve the power quality, like StatComs, eStatComs, and similar solutions that can contribute to more stable grids. You mentioned renewables. That's another huge opportunity. We know that renewables are depend on the availability of the energy source, right? Is it wind? Is it even waves, right? Of course, sun. And we can use this energy only when this is available. Still, what if we install some storage capacities that can keep this energy stored and then unlock it when it's needed? Can we control in a better way power flows in the grids and again unlock those pockets of the energy that are actually available but maybe are not connected in a proper way to the data centers itself. So bringing this link between the need and when the operation of the data center and the energy in the data center is needed, as well as the utility and the grid, is the opportunity to bring this flexibility, to bring also, of course, through the digitalization, through the energy management system, network energy management system, linking everything into one seamless system that orchestrates together and understand what are their loads, what are the needs of the loads, and understand what is the energy generation capacity and what are the opportunities in the generation to have a way more flexible operating model and maximize the utilization of the old energy that is generated or can be generated, but maybe at that moment is not really needed or utilized and can be utilized in maybe a later stage or can be stored and right planned to be used later.
Okay, so there you sort of described particularly at the end there, the way that digital technology can help. But on the other, if you like, at the other end of the supply chain, maybe we've got demand for transformers and switchgear. That's rising. So, mechanical components. What challenges does this create for the supply chain, and how can the industry respond in a timely fashion? I mean, I did an interview yesterday. Only yesterday, someone was saying, that switchgear lead times are getting ridiculous as well. So, just your thoughts, I suppose, as to that part of the supply chain and what needs to happen.
Yes, you're right. And of course, the whole industry acknowledged that nobody could predict and nobody could plan that that we will need to build a new Spain, right? As I said at the beginning, for the generation and for the transmission and for all the electric equipment that is needed. And we need to understand that the speed of the evolution and speed of the new technologies in the IT sector, in the AI sector, right? Let's take the example of the AI rack densities. The non AI racks are around 10 kilowatt per rack. And this throughout the years, if I look 5 or 8 years ago, the rack density was no more than 4 kilowatt, right? But it scaled to 10 kilowatt quite slowly, quite steadily. We could predict this. Now we have the AI racks, which are operating at 100, 135 kilowatt. And NVIDIA already announced in the half two of 2027, we will have a 1 megawatt rack. So the scale of the need of the energy in the same footprint is becoming tremendous. And the whole planning needs to happen around it. So early prediction, early communication, working hand in hand together with our partners like NVIDIA or our customers, etc., or the hyperscalers, colocation providers, as well as the other players in the data center industry, other OEMs, EPCs, etc., to really understand what is the demand, to plan ahead, to work on the standardization. That's a huge opportunity as well. So we have overcome with many of the customers those challenges, right, on accessing to the availability of the critical equipment like transformers, like high voltage circuit breakers, high voltage switchgear, and other equipment, which is, I would call it, on a critical path, right, to energize the data center, working more in a partnership way, working in a way to understand where the next data centers are going to be placed. Can we do some standardization? A lot can be done in advance in planning, right, which really shortens a lot the lead time for the transformers, for the switch gears, for any of the critical equipment, which can then match actually the customer demand and customer need for the energy. And of course, it's not only right planning and so on. We are acknowledging the need. We have invested 1.5 billion for the new capacities in the production. So that's two, 3 times more increase of the capacity than planned, for example, for the transformers. So we are following right the market need. We are going even ahead of the market need because we understand that this is gonna continue, and we will need more energy if we really wanna unlock the potential of the AI data center. So in short, it is real. The demand is real. The AI is happening. We don't see it slowing down. The solution is working in that partnership way. So the simple process of okay, when I have a one transformer needed, I just order it and I get it. That's not happening. It really needs to be a good planning or collective planning, and this together with this, it's the and together with this is also what we are right investing, and we also announced actually we already did this 1.5, and we announced additional 6 billion of investment by 27 to further increase the capacities. So we are acknowledging and we are working ahead of this demand to ensure that all the equipment is available and we can unlock the full potential of the AI actually.
Mm. Well, thanks for that. And maybe then you've mentioned obviously a lot of technologies as we've gone along. I'd just be interested as to your thoughts as to which of those might be most critical when it comes to powering next generation data centers, things like, battery storage, renewables, and hybrid systems. What technologies, and maybe also sort of part two, we've got fuel cells and advanced backup systems such as your HyFlex. How are those changed the way data centers think about things like resilience? And so I guess it's just, what are the technologies to look out for them, and what do they bring to the party?
This is an excellent question. And the point is, yes, even the industry realized that there is, of course, a limited amount of energy, generally speaking. And one way is also how to bring this energy in a more efficient way. And efficiency is not anymore how much energy I save. It's now really how much more energy I can bring to the AI data center, how much more tokens I can produce. So if I want a financial and business calculation, I'm not doing it following the what's the price of the electricity or what's the price of the electron. I'm calculating on what's the price of a token produced. So what more I can get if I bring more energy. To link this with your question, it means that we all are working already in improving the technologies on the existing equipment that is bringing the energy to the data center, and also innovating the data center architectures and the equipment in the data center itself. And as Hitachi Energy, we are developing the grid to rack solution, as we call it. So really the whole energy distribution from the connection to the energy assets and or to the grid, of course. So throughout the high voltage transformers, medium voltage systems, and then comes right then next generation of the data center are going to be supplied directly in the 800 volt DC. This is announced by NVIDIA. This is a change again, mainly actually because of the 1 megawatt rack, because it's impossible to distribute in this rack with a 54 or 48 volt as it's being done in the past, because the cables and everything would be very bulky and very large. Still, this 800 volt unlocks a huge opportunity to improve the energy efficiency of the data center, to reduce the conversion stages, to innovate around the rectification and transformation of the voltages and currents. In other words, the whole industry is working to directly connecting from 34.5 kilovolt on the AC side to 800 volt on the DC side. And as Hitachi Energy, we have all the components on this critical path. So we are of course, well known for the substations, for the transformers. We are also one of the market leaders when it comes to the power electronics, to the semiconductors. We have our own semiconductor production. So we are also innovating on the semiconductors. We are building solutions like battery energy storage system or like EV chargers, etc., which are built on the semiconductors. And as well as the full systems like high voltage DC connections, right, which connect the large sources of energy with on the long distances. And we are using, and we of course have the full system integration capabilities, and we are leveraging all this again to create, and together of course with our partners on the medium voltage and low voltage protection side, to create the full system which is optimized for the efficiencies, which is optimized for the reliability. So these are some of the changes. So we are looking at the solutions like solid state transformer in the future, or the medium voltage rectifier, and other systems which again contribute to the efficiency, which contribute to the footprint of the data center. And of course, helping to simplify the design and helping to design it in a better way. And like you said, and this is related, of course, to the data center architecture itself. Then it comes to energy availability, and I would say here the battery energy storage system is definitely one of the newer, I would say, components being installed in the data center, being needed more and more. But the battery energy storage system, which is really tailored and built for a data center to make sure that the critical power is available to operate as also the emergency backup source, and alongside to also operate as a supporter of the grid, contributes to the ancillary services, and make sure to again balance between the one dynamic of the load side and other dynamic of the generation side. And finally, you said, right, alternative sources of energy, fuel cells, that's one example. It can high flex, it can unlock even at a very early stage, right, some improvements in the sustainability or the availability of energy while the data center is being built before you have any generation asset on site, right? And you can already generate the electricity and start building your data center. That asset can be after used again for all the services that we mentioned, supply the data center, or access of the power, or again the ancillaries, as well as, of course, right, if we look more to the solid oxide fuel cells, which also can work with the gas and afterwards can be converted to the more sustainable ones, right? The hydrogen becomes available at scale, can be converted to hydrogen and continue to generate the electricity for the data center with the hydrogen. So a lot of innovation, a lot of new things, a lot of new products, solutions. But I would say if we really want to unlock this potential of the new technologies, we need to look at it from the system perspective. We need to look at it from the solution perspective, and we really need to design it all together as the data center community. Let me call it that way.
Yeah, maybe just in finishing, a couple of questions. So the first one would be how you think the data center energy relationship will develop over the next decade, and is there anything that data center operators in particular should be doing today to sort of prepare for what's coming?
Yes, I would say early planning is the key. We really need to understand the demand, understand what we are doing. The main opportunities is working together. So there's no single company in the world which can build the future AI factories alone, or which can do this alone. We need to work across partners who are actually building those new technologies which drive AI, such as NVIDIA. We need to work along the end users and customers, such as hyperscaler colocations, and NeoCloud is a new, very important part of the data center community, let me call it that way. We, of course, need to work across the OEMs from all different aspects: cooling, electrical, generation. I would say the generation is a little bit new to the data center business and game, and we are partnering with some of those generation companies to bring the solutions all together. Then, of course, the EPCs and the system integrators and the other parts of the community, which are really putting all the systems together. And finally, of course, very important, the investors, the financing, and understanding really how all these ecosystems are being built together. And extremely important, the utilities itself, because you really need to understand where the next data center is going to be. Excuse me, how the power is going to be distributed to this data center, and can we enable maybe with those energy generation capacities or similar capacity within the data center, how we can be again active contributor of the grid and contribute to the grid stability and contribute to the next assets within the grid. So that's a huge opportunity right in front of us that we can collectively do, and this is the next step in the industry, definitely.
And maybe just finally, I mean, Hitachi Energy, as you've outlined, you start at, shall we say, the most basic level, if you like, the semiconductor, the chips, the power electronics, and play a long way up the supply chain. But just be interested as to what you think your role and maybe even responsibility is within that sort of ecosystem we've discussed. How much should you be leading the way, and how much should you be responding to other partners and parts of the overall data center ecosystem?
Thank you very much for that question. And I would say the role of Hitachi Energy and similar more grid connection, high voltage companies and so on was somewhat limited in the past to the very large data centers and to the data center which would require the grid connection and so on. Nowadays, as we build those gigawatt AI factories, as let's say a normal data center is 100 megawatt plus, we are really playing a key role in the whole ecosystem. And we are realizing how we can innovate together with the customers, how we can really drive the industry forward. And we are already starting to bring some of the solutions that maybe in the past were not needed or were not used by the data centers, such as battery energy storage systems, such as STATCOMs, e-STATCOMs, such as other power quality devices which belong to the low voltage that we have. DC distribution is something that we've been working for years, ages. There were periods right in the data center industry when DC was becoming a topic, but I would say it never really happened due to many reasons. And we will unlock right the Pandora box if we speak why in the past we never went to the DC, though it seemed logical. Now the DC is real. The DC is real simply because the rack changed. The rack is supplied directly in the DC distribution with the 800 volt DC. And again, this is larger power. This is large power electronics. This is where, again, Hitachi Energy has the competence, and where, again, we are driving the industry forward together with our customers, together with our partners, to innovate towards the next generation of the rectification and of the transformation of the energy, right? Directly from the AC to DC in the most efficiency, in the most scalable way. Together with these solutions like fuel cells and other alternative sources of energy is what we are innovating and investing. And finally, we shouldn't forget, right, the utility and the grid is where the energy is available, is where actually you can also find new capacities, and where we are innovating together with the data center industry. And I need to say that Hitachi Energy was one of the pioneering companies in our domain to start working closely with the data center customers. So we know our customers, we know the data center industry. Traditionally, utilities are our main market, and utilities are where we are working together. And our goal is really to act as a bridge between the two. And finally, I would say as a umbrella on top that links all these together are all the energy management systems and digital solutions that can orchestrate all those physical assets that we have installed in the grid, from the generation assets that we again have, right? Because we have the network energy management system and more flexible system, more adopted for the microgrids. And we have been and we are operating the microgrid systems together with what knowledge we have, even as a Hitachi Energy is part of the Hitachi group, which has a large competence in the digital and in the IT space. So we understand how the AI works, how the digital load works, how the rack works, right? We are one of the largest manufacturers of the of the storage systems for the racks, right? With Hitachi Vantara. So we are bringing all these systems together, and in the future, really, we are innovating with the customers to bring the hardware piece and the install base piece and the digital piece on top that would orchestrate and again make sure that we bring the efficient, reliable, sustainable energy to the data center in the future, together, of course, with our partners and with all the companies of the data center ecosystem. We can do it only if we do it together. So there's no way that anyone can do it on their own or isolated without co-innovating together with the industry.
Alexander, it's been fantastic to chat, and again, and the image of building a new Spain, I think, is a very powerful one. So thank you for that. But it's been great chat, and I say some brilliant insights into what's going on within the data center space when it comes to energy, and also obviously what Hitachi Energy is doing. So really appreciate your time. Thanks so much.
Thank you very much, Philip, and it was a pleasure to discuss how the future of the data center will look like.